Okay, let's do the same thing with u equaling the denominator. So if I let u equal cosine, u equal sine, the derivative is cosine. So look at that. If I have 1 over sine of x times cosine of x dx, this is my du, and this gives me 1 over u. So this is ln of u, and then I get to put the ln back in. And remember those absolute value bars. Okay, so here I have e to the x's everywhere. Well, I do see that e to the x is inside of both of those trig functions. So we always want to let u equal an inside function. So when I take the derivative, I get another e to the x. So I'm going to write these two things beside each other at the end. So this is my du. And here I get secant of u, tangent of u. So taking the antiderivative of secant tangent is secant plus c, and then I get to put the e to the x back in. Okay, this one's a little challenging here, so I'm just going to rewrite it. Okay, so I see letting u equal e to the negative x. The angle inside is a good choice. So when I take the derivative here, I have chain rule, right? And I'm looking at this, and I'm looking at this. So let's just rewrite du as negative 1 over e to the x dx, right? That negative there means in the denominator. There it is. So negative du will equal 1 over e to the x dx. So let's do it. So I get cosine of u, and then a negative du. So take the time to pull the negative outside. The antiderivative of cosine is just sine. And then put the negative, or put the e to the negative x back in. And there we are.